right, so hopefully you've all had a chance to go over the worksheet answers that I gave you for the last two worksheets. And if they're not making sense, you're here because you want a little bit of extra practice. So I'm going to give you go ahead and give you an integral. Let's give you a triple integral. Let's say we have dz, dy, dx. We don't have any function in there, so this is just going to give us the volume of this region. My x values are going to go from 0 to 1. My y values will go from rad x to 1, and z will be from 0 to 1 minus y. And I want to rewrite this triple integral. Let's go alphabetical order, dx, dy, dz. So when I have this, I know that I'm just going to have to find the volume, so I'm going to have to sketch what this is going to look like. So here's my coordinate axes in 3 space. My x values go from 0 to 1. My y values in terms of x, so we're just sketching in the xy plane. My y values are going to go from rad x to y equals 1. So this is the projection in the xy plane. And then z is only defined in terms of y, so z is defined by this plane z equals 1 minus y. And because it's not the entire plane, but the plane is cut along here, it's going to look like this nice, beautiful wedge here is what we're going to be finding the volume of. So now that I have my region, I can go ahead and I'm going to start on the outside and work my way in. I can see that my z values go from 0 up to this point. That hits at 1, so my z values are going to go from 0 to 1. Now my y values are going to come this way. So my y values are going to go from 0 out to the plane, because this is in terms of z. So if z is 1 minus y, y is 1 minus z. And now my x values, well, my x values are going to go this way. They're going to go from the yz plane, and they're going to extend this way until they hit this parabola. So my x values are going to go from 0 to y squared. All right, so let me give you another one. Let's say I have the integral from, we'll do -1 to 1, x squared to 1, 0 to, we'll do the same plane, 1 minus y. And we'll go from dz, dy, dx to, we'll do the same order as before, dx, dy, dz. So at this point, the best thing for you if you're trying to practice is to go ahead and pause the video and see if you can get the same answer that I'm going to get. Again, I'm going to sketch it. I'm a sketcher, and I think it really helps me to figure it out. So when I have my coordinate axes here like this, I can see that my x's in terms of y, my x's actually go from -1 to 1. So I'm going to need that back piece of the x-axis. My y values go from a parabola to y equals 1. So here's y equals x squared. Here's y equals 1. So this is my projection just using these two integrals in the xy plane. And then again, drawing the same plane I had up here, I can see that this is going to slant and make a lovely piece of Gouda. So it's going to go up and come back down, right? And so hopefully you can see that with my 3D picture. So now, again, starting on the outside, working my way in, my z values need to be numbers. My z values go from 0 to 1. They're always positive. My y values go from 0 out this way until they hit this curvy part, or this plane, right, this pitched part. So they're going to go from 0 to 1 minus z. And my x values are defined here. So my x values go from this side of the parabola to this side of the parabola. So my x values are going to go from negative rad y to rad y. So hopefully this one worked out for you and you're feeling a little better about your triple integrals.